So the third lesson in this unit refers to cost analysis. Generally speaking, this is taking the surface area and volume questions and having a practical application for them. Okay, so there's a couple things involved with these questions. The first thing is you're going to notice the questions are a little bit more elaborate and take a little more time. So it's really important that you show your steps and kind of organize your work carefully and neatly. Don't scribble all over the page. Work kind of in sections and keep things organized the best you can. You might even want to put little headings so that if I'm looking at it, I know what you're doing in each section. Okay, second thing you should do is make sure that you're consistent with your measures. So sometimes you're going to see a question that has meters and centimeters, or yards and meters, or square this, or cubic that. Make sure you consider the measurements. Now, we've spent some time on that in the last lesson. That's going to come into play for sure. Okay, last thing, or last two things. When you purchase construction materials, a lot of times you can't just buy exactly what you need. You have to buy like a whole unit. Like you can't buy half a can of paint, or you can't buy, just a few, say, ceiling tiles. You'd have to buy like a whole pallet or whatever it is. So you have to consider that when you're doing a question as well. And the last, make sure you're keeping track of taxes. So let's look at the first question. It says a grain bin is made of aluminum, and it's in this shape. It says that how much the aluminum costs, and we're supposed to figure out what it would cost to build this bin. Okay, now if you think about paint and aluminum, we're talking not about volume, but we're talking about surface area. How long is it going to take to make this shape, or how much is it going to take to make this shape? So the first thing we need to do is figure out the surface area of this shape. And there are three parts. There's this kind of half circle, which is the top. There is the cylinder, but in this case we don't care about the tops and the bottom. We just care about the sides. Okay, and the last is the cone. And here again, we don't care about the top of the cone or the circle, just like we don't care about that part of the sphere or hemisphere. So how do you find the surface area of each of these? Well, the surface area of a sphere is 4 pi r squared, but this is only half of a sphere, so we're going to divide by 2. Okay, the surface area of a cylinder, if you remember, is 2 pi r squared plus 2 pi r, sorry, I think it's just, 2 pi r h. Okay, and if you remember correctly, the 2 pi r squared refers to those two circles that we're not counting. So in this case, we really only want the 2 pi r h. And last, the surface area of a cone is pi r squared plus pi r s. And again, we don't want the circle. Okay, so let's find each of these surface areas. 4 pi, the radius is 12. Okay, so we're going to get, this is 2 pi times 144. We'll get the calculator out in a second. Here you're going to get 2 pi, the r is 12, and the height, oh, is that 2.4 or 24? I think it's 2.4. So I just got to go back here. This is 1.2. So this is 1.44. And this is not 12, it's 1.2. And then the height is 3.1. Okay, and the last one, pi times the radius, which is 1.2, times the slant height. Now, the slant height here is not given. Okay, how do you find that? Well, we use Pythagoras on this triangle. This is 1.2, and this is 2.8. So to find x, we're going to go 1.2 squared plus 2.8 squared is x squared. Okay, so I'm just going to grab the calculator here, and we'll do these questions. Okay, so found out a few things here. I found out my length of X is 3.05. So let's be careful. That was 3.046 something. So when I round off, you'll notice that over here I put in 3.0, not 3.1, because it doesn't round off there. Okay, and so I've got these three surface areas. I've added them up, and the total surface area of the shape is 43.7 meters squared. Okay, so we're supposed to calculate two things. We're supposed to calculate cost of paint and the cost of the aluminum. Okay, so let's read a little closer. Let's do the paint first. Paint for the bin costs $8.75 a liter and covers 12 meters squared. So we have 43.7 meters squared. If we divide that by 12, because 1 gallon covers 12, then we get 3 point something. Okay, let's quickly calculate that. So 43.7 divided by 12 is 3.64. But you know that you can't buy part of a gallon, so therefore we're going to need, oh, hang on, we need to cover it twice. So you're going to need this much paint times 2, so that's 7.28. So how many gallons are we going to buy? Therefore we need 8 gallons. Okay, because you can't use part of a gallon. And then the cost of aluminum. It says for the bottom part, the aluminum costs $9.50 a square foot. So this is the bottom part, the 11.3. So 11.3 square meters times 950. That's going to be part of it. And then we've got the other two parts. So 9 plus 23.4, that's 32.4, and that's, I believe it's $6 a square meter. Okay, so we're going to multiply those two things. Okay, so 11.3 times 950. So that's 107.35. And then we've got 32.4 times 6. So that gives me 194.40. So what does it cost? To paint the bin costs $8.75 a liter. So now let's do total cost. We've got 8 gallons times $8.75 plus 103 plus 194, and we're going to multiply that all by how much tax you pay. Now tax now is GST is 5% and PST is 7%. So we're going to go 12%. So we're going to multiply by 1.12%. Okay? Because we want the original plus the tax. So let's see what we got here. Got 8 times 8.75 plus 107.35 plus 194.40, and I'm going to go enter. So that's the cost. We're going to multiply that by 1.12. and we get $416.36. That's the total cost of this bin. Okay, so take a break. I'd like you guys to try example 2, and then we'll do it together. Alright, example 2 is a little bit different because you have to understand that there will be wastage here. There's going to be some of the tin is going to be wasted. So it says here we need to cut out these 2 pieces, and we're cutting it out of a piece that is 4 by 8. So 4 by 8 means 4 feet by 8 feet. But if you notice here, these measurements are all in inches. So what we need to do is we need to change this to inches. This is going to be 48 inches, and this is going to be 96 inches. And we have to try to figure out how do these 2 pieces fit into a sheet like this. Okay, and I mean, I know there's more than one way to do this, but basically you have to kind of justify how you're going to cut it out. So the way I'm looking at it is if I stick this piece right in here, and I know I can do that because this is actually 7 inches long. So if I stick this piece right in here, and we make this one piece, so it would kind of look like this. You would have something like this, and then that other piece would fit like in here. So we basically have to kind of cut out a piece that's this big and see how many times it fits into that big sheet. Okay. If we look at this as being 9 inches, there's 2 inches here that's overlapping. This is going to be 7 inches, meaning the entire length is 16 inches. Okay, and the entire height is going to be 4 and 5, so this is going to be 9 inches. So what we've got is a rectangle that is 16 inches by 9 inches, and we have to see how many of those we can fit into here. Okay, well, first of all, let's look at the 16 inches and see how it fits with the 48 inches. If you do 16 inches, you're going to find that you can do it 3 times. Okay, so we can fit 3 across, and then how many times does 9 inches fit into 96? Well, if you go 9 times 10, you're going to get 90 inches. So let's look at that. So you're going to have 3 this way, 3 pieces, and if we go 9 inches here, you're going to get 10 of them. That's going to get you 90 inches. So again, there's going to be some waste at the end. Okay, so 10 times 3, we're going to be able to cut out 30 of these pieces. Okay, so how many of the parts can he make from one sheet of tin? We're going to say 30 pieces. Now you would have to justify that somehow. You can't just say, I think it's 30. You'd have to say, well, look at my 2 pieces put together make up this 9 by 16 piece, and then I can see how many times it can fit in there. 3 by 10. Okay, part B is if the 4 by 8 sheet of tin costs $120 and he charges $15 labor for each part that he makes, how much could he charge for each part in order to cover the cost of material? Okay, well, we've figured out that there are 30 pieces. So there are 30 pieces, because remember the 2 pieces make up one, whatever this is, this duct thing that he's making. Okay, and he can charge $15 labor for each part that he makes. So we're going to go times 15. So he can make $450. All right, but it costs $120. Wait, let me make sure that's right. How much should he charge for each part in order to cover the cost of material and labor? Okay, so this 450 is the labor that he would charge, and then he's got $120 of parts. I guess this doesn't include tools or whatever else he has, but he should charge $570 per sheet to make these pieces. Okay? Alright, let's do number 3. You've been hired to finish someone's living room. The room is 23 feet by 14 feet. Let's just draw that. So it's 23 feet and 14 feet, and has 2 doorways and 4 windows. Calculate the cost of paint for the walls of the living room, including taxes. Use 1 coat of paint primer and 2 coats of finishing paint. The walls are 8 feet high. Okay. So, from each of the, like this is a top view here. So let's draw each wall in. Okay? You're going to get a wall that's 23 feet long and 8 feet high. And there's actually 2 of those. Okay, there's 2 of those. And then there is a wall that is 14 feet by 8 feet high. And again, there's going to be 2 of those. Okay, and then we've got some doors and windows we're going to subtract. So let's find our area here. So you're going to have 23 times 8 times 2. You're going to have 14. Oh, pen's not working. Hang on one second. So what we're going to do is we're going to add this up, and then we'll subtract the parts that are missing, like the windows and the doors, because you don't have to paint those areas. Okay, so 14 times 8 times 2. So let's figure out what that is. That's 184 times 2 is 368. So this is 368, and this is square feet. And then this is going to be 112, 224 feet squared. Putting this together, we're going to have 592 square feet. Okay, now let's think about the doors. So area of the doors and windows. The door is going to be 3 feet by 6 feet, 8 inches. Alright, and it says there's 2 of those doors. And then the windows are 4 by 2, and it said there are 2 windows, I believe. Are there 2 windows? Oh, 4 windows. Okay, so let's figure out this amount. So 4 times 2 is 8. This is 32 feet squared, so we're going to subtract that. Now this is a little trickier. We have 6 feet 8 inches. 6 feet 8 inches. We can't just multiply that, because this is not like a decimal. This is not 6.8. Alright, we have to change this either all to inches or all to feet. Okay? We could do it either way. If we want to change this to inches, 6 feet is 72 inches, 8 inches, so this is 80 inches. Excuse me. So we could do it this way, but let's change the 80 inches to feet because everything else is in feet so far. So if we divide 80 by 12, right, we're going to get 6, and then there's 8/12 left over. This is going to be 6.67. Okay, so we're going to go 6.67 instead of 6 feet 8 inches. Now, if you can on your calculator, or if you can leave it as 6.66666, repeating, that would be better. But let's multiply that. Okay, so we're going to get 6 point, and I'm going to go 0.666666, do a whole bunch of them. Okay, times 3 times 2 equals 40 feet squared. So we're going to subtract that from 592. So subtract 72. So this is 520 feet squared. This is the surface area of the room. Okay. Now what are we supposed to do with it? We're supposed to paint it. Okay. It says that calculate the cost of paint. 1 gallon of paint primer covers 300 square feet. So just doing a quick look, we need 520 square feet. We're going to need to buy 2 gallons, right? Because 300 square feet is not going to cover the 520, so we have to buy the 2 full gallons. Okay, so let's write that down. Primer, we need 2 gallons. Okay, and then the other paint, the rest of it covers 400 square feet, but we're supposed to do 2 coats. Okay, so if we did 2 coats of 520, 2 coats, we would need to do twice that, so 1,040 square feet. Okay, and if you looked at 400 square feet comes in a can. If we divide this by 400, you're going to get 2 point something. So it looks like we need 3 gallons of paint. Okay, if you're not sure how I got that, we have 1,040 feet squared that we need. If we divide that by 400, because that's how much it covers, you're going to get 2.5 something something. So you know we need more than 2 gallons. Okay, so primer costs $29.95 times 1.12, right? Because it says GST is 5 and PST is 7. And then we're gonna, this is $44.95 times 1.12. Okay, so just check out what we're doing here. 2 gallons, 2 times $29.95, whatever that is, we're multiplying by 1.12 to give us the cost including taxes. Okay, so 2 times $29.95 times 1.12 equals. So this is $67.09. And then we're going to do 3 times $49.95 times 1.12. And that's $167.83. So adding those two up, we get $234.92 to paint it. Okay, just a quick comment here. Notice the paint and primer must be purchased in whole units. That's why we had to round up. Okay, then B, calculate the number of boxes of wood flooring needed to cover the living room floor. Okay, so this was A. B, it says 1 box covers 2.5 square yards. Well, first of all, let's find the area. The area is 23 times 14, but this is going to be in feet. Okay, so let's do that. 23 times 14, so 322 square feet. So we need to change this into yards. How do we change square feet into yards? Well, 1 yard is 3 feet. 1 square yard would be 3 feet times 3 feet. So that would be 9 feet squared. So if we divide this by 9, it'll tell us how many yards it is. So 322 divided by 9, 35.78. So 35.78 yards squared. Okay, so that's the area of the floor. Now we need to figure out how many boxes. So each box covers 2.5 yards. So to find out the number of boxes, we're going to take 35.78 and divide it by 2.5. Okay. This is going to be 14.311. Now, can you buy 0.3 boxes? No. So we need to buy 15 boxes of wood. Okay. Oh, it says we need an extra 5% to account for waste. So let's go back here, and before I decide that it's 15 boxes, I better double check that, because I'm going to need more than 14.31. I need to include 5%. So let's multiply by 1.05. So this is kind of like an extra 5%. Okay. So let's multiply by 2.5 to get back to our number. And then let's go times 1.05. Yeah. Okay, that's not what I did here. So let's back this up a little bit here. Before I divide by 2.5, I'm going to multiply this by 1.05. This is saying this is how much more area there is. Okay, so that's 37.57. Okay, and now I'm going to divide that by 2.5 to find out how many boxes. So I need 15 points. Oh, this is cruel. I need 15.02 boxes. What would you do? Would you buy 16 boxes knowing that you've already accounted for 5% extra? You might just say, you know what, I'm just going to buy 15 boxes. Now there's a couple things to consider there. Do you think you're going to have a lot of waste? Then you should buy 16 boxes. Can you just go to the store and get another box anytime you want? Then just buy 15 boxes. If you're going to have to special order it and you're not going to be able to return it, I mean, then you're going to have to make a pretty tough choice, because if you can't get it later, you might want to buy the extra, but if you can't return it, you might not want to buy the extra. So those are some things to consider when you're making your final answer. Okay? So I have one more question to do here. I'm going to make another video to do that. You can already begin on the final assignment. Okay, the final assignment is here. I will assign the questions in the next video.